Welcome to aminacademy.com. In fluid mechanics, let us discuss about absolute, gauge, atmospheric and vacuum pressures. Here, look at this figure. Let it be here absolute zero pressure, this level. This absolute zero pressure. Now, this atmospheric pressure here. This one is vacuum pressure. Here this gauge pressure. This absolute pressure. Now, first one we'll discuss about absolute pressure. Absolute pressure is defined as a pressure which is measured with reference to absolute vacuum pressure. Is defined as the pressure which is measured with the with reference to absolute vacuum pressure, with reference to absolute vacuum pressure. Absolute vacuum pressure. Now here from the vacuum pressure, with respect to vacuum pressure, absolute pressure is defined. That means here absolute zero pressure is here. From the vacuum pressure it is down. Next here gauge pressure. Gauge pressure is defined as the pressure which is measured with the help of a pressure measuring instrument. Is defined as the pressure which is measured with the help of a pressure measuring instrument. Pressure measuring instrument. That means by using a pressure gauge or manometer, like we can measure the pressure of the instrument. Means pressure inside the volume of some tank, that inside the machineries you can find the pressure. That is called gauge pressure. Here in which the atmospheric pressure is taken as datum. For this gauge pressure, atmospheric pressure is taken as reference, reference datum, reference or datum. That means here the gauge pressure is from the above atmospheric, how much it is you have to measure with the datum of atmospheric pressure. That is called a gauge pressure. Then third, vacuum pressure. Here vacuum pressure is defined as the pressure below the atmospheric pressure. Vacuum pressure is defined as the pressure below the atmospheric pressure. Here this vacuum pressure is here, so it is measured below the atmospheric pressure. Fourth one, next one is absolute zero pressure. Here absolute zero pressure is measured further below the vacuum pressure. Further below the vacuum pressure, sir, is defined as the pressure below atmospheric pressure. Actually it is well below, means here after that we cannot go further pressure reducing, means at this pressure more molecules are inactive. That is called a absolute zero pressure. Now we can mathematically can define all the things. Look here, mathematically we can give absolute pressure is equal atmospheric pressure plus gauge pressure. That means we can view P absolute equal P atmospheric plus P gauge. Here absolute pressure is atmospheric plus gauge. Then next one, we'll give little space for here. Next is vacuum pressure equal atmospheric pressure minus atmospheric pressure minus absolute pressure. You can write P vacuum is P atmospheric minus P absolute. Here atmospheric pressure is at a sea level at around 15 degree Celsius is 101.3 kilonewton per meter square, which is equal 10.13 meter, which is equal 10.13 Newton per centimeter square. And atmospheric pressure head we can write atmospheric pressure head is around 760 mm of mercury or 10.33 meter of water. This is atmospheric pressure. Now let us do one problem regarding this. What are the gauge pressure and absolute pressure at a point 4.5 meter below the free surface of a liquid having a density 1.58 kg per 1.58 kg per meter cube if the atmospheric pressure is 755 mm of mercury, the specific gravity of mercury is 13.6 and density of water is 1000 kg per meter cube. Now let us do this problem. Here first depth of liquid, that is Z equal 4.5 meter. Density of liquid equal rho. One is given as 1.58 kg per meter cube. Datum, that is atmospheric pressure head. Atmospheric pressure head Z0 equals 755 mm of mercury, mm of Hg, which is equal 755 over 1000, 0.755 meter of Hg. Now atmospheric pressure. Atmospheric pressure is P ATM equal rho 0 G Z0. Rho 0 is 13.6, rho of mercury 13.6, G is 9.81 and Z0 . then rho 0.755. Let us calculate this. 13.6 into 9.81 into 0.755 equal 100.73 100.73 here 13 point into 1000 also, because it is 13.6 into 1000 density of water. Then specific gravity is 13.6, so density is 13.6 into 1000 equal 100.730 Newton per meter square. Therefore, pressure at a point which is a depth of 3 meter at a depth of 4.5 meter at a depth of 4.5 meter, that is pressure equal density rho gh. Density is 1.58 and G is 9.81 into 4.5 into 1000, because here specific gravity you have to find with multiplication of 1000. Therefore, we will calculate this 1.58 multiplied 9.81 multiplied 4.5 multiplied by 1000 equal 69749.1 Newton per meter square. Therefore, gauge pressure is atmospheric pressure is 100.730 plus 69749 plus 1, which is equal plus 100.730 equal 170,479.1 Newton per meter square. So we got the final answer. We have done. Please subscribe our YouTube channel.